Hello and welcome back, everybody. Today in calculus, we are looking at something called the representation of a power series. So prior to this, you learned about certain power series, and I've listed those two below actually. And what we want to do is use those two power series, or basically what we have in our toolbox, and then use that to evaluate other power series and also find their radius of convergence. So basically, kind of like take what we know and expand upon that to see what else we can actually find out. So literally, that's what's happening right here. So what we want to do is, as I said, use what we know to solve for other power series. And in terms of what we know, we only can work with the two following series right now. Okay. By the next section, you're going to have more than this. But for right now, this is basically our, two things that are in our circle, and then we're going to have to expand upon that. So the first one, we've kind of derived it and, said it plenty of times. It's going to be 1 over 1 minus x, and that is equal to 1 plus x squared plus x cubed and so on, which is the same thing as the summation of n is equal to 0 all the way to infinity of x to the nth power. Its interval of convergence is from -1 to 1. And then the other one that we know is e to the x, and that is supposed to be equal to this guy over here. And this is going to be its summation form of it. And its interval convergence is going to be for all the values of x that is going to be all real numbers. So these are the two things that we have to work off. Okay, so let's go ahead and see what we can do with those then. In the first one, what I want to do is, well, actually in all these problems, what I want to do is I want to find the power series for each of the following and also the interval of convergence for each one of those. So here you can see I have 2x divided by 1 minus 2x quantity squared. So in terms of like how we're going to approach this, we're going to think about, okay, well, let's go ahead and take what we have and how are we going to build what we want. So the closest thing that is going to be equal to this expression over here is going to be 1 over 1 minus x. And you're thinking to yourself, okay, well, what do I have to do to this guy in order to get it to what I want? So here, what I can do is I notice that on the bottom, there is a 1 minus 2x. So maybe what we can do is replace the x with 2x then. So 1 over 1 minus 2x. And I'll show you what's going to happen with all the other stuff when you do that. Then the next thing is I've noticed that we have 1 minus 2x quantity squared. So that means that in terms of like what we have right now, if I take its derivative, that's going to get closer and closer to what I want. So here, if I take the derivative of what I have, which is 1 over 1 minus 2x, then that is going to give me the 1 over 2x quantity squared that I want. And as a result, by the chain rule, that's going to give me a -2 on top. And finally, notice that there is going to be a x on top, and then there's the negative that's going to be gone. So we can take that and maybe multiply by x, and then divide by 2, and then we're going to get our result then. So then that is going to give us our 2x divided by 1 minus x, 2x quantity squared. Okay, so let me kind of show you what I mean by all of this, first of all, okay? So first, we said that we have 1 over 1 minus x to work with, and that is supposedly equal to 1 plus x squared, and then plus x to the third, and so on, and so on, and so on. And then also writing out its summation form, that's n is equal to 0 all the way to infinity of x to the n, and my interval of convergence is from -1 to 1. So that's where our starting point is. What I want to do is take this equation right here and replace all the x's with 2x. Okay, I'm going to take this equation and replace all the x with 2x. So 1 over and then minus, and then here you can see I'm going to replace all your x with 2x over here. And on the right-hand side, what will then happen is I am going to get 1 plus, wherever you see x, you're going to get 2x now. So this is going to be 2x over here. And then plus the next part is going to be 2x squared. And then the next part is going to be 2x cubed, and so on and so on and so on. In terms of how does that change this part right here, that's going to be the summation of n is equal to 0 all the way to infinity of 2x and then raised to the nth power. My interval of convergence is going to change exactly the same way too, because I'm replacing all the x with 2x. So -1 is less than x times 2x, okay, is less than 1. So now that modifies my interval of convergence so that it's -1/2 is less than x is less than 1/2, okay? So there you go. That's going to be my first modification because of what I just did. The next step is I'm going to now go ahead and take the derivative of this equation, right? Because that's the next step to make it look like what I want. So I'm going to go ahead and take the derivative of this thing, okay? So the derivative of 1 over 1 minus 2x, and according to what we wrote earlier, that is supposed to be equal to negative 2 divided by 1 minus 2x quantity squared. If I'm taking the derivative of the left, I definitely need to take the derivative of the right. So let's go ahead and write that out. So the derivative of each term, 1, the derivative is going to go to 0. Then the second part, the derivative of 2x, that is going to go to 2. And then the next one, the derivative of that, that is going to be equal to 2 multiplied by 2x, and then multiplied by 2. And the way that I looked at this one was that I basically look at it using the power rule and the chain rule. Take the 2 from the exponent, bring it down to the bottom, and then multiply by 2 because the inner function, there is a 2 in there. The next part right here, if I take its derivative, that's 3 multiplied by 2x raised to the second power multiplied by 2 because of the chain rule again. And you basically need to write as many terms as you need in order to see what the pattern is. Here, I'm just going to go ahead and write one more just for, for your curiosity. The next term above it is supposed to be 2x to the 4th. So its derivative is going to be 4 multiplied by 2x raised to the 3rd power multiplied by 2. And note all the time, I did not write it in its simplified form and then take its derivative. If you want to do it that way, that's totally fine. But I think this is in its purest form like this, you'll be able to see the pattern better and therefore be able to write the series as a summation form a lot better. So here, this is now what we're going to get. The summation, and then now this is the part that's going to be really, really strange, and we have to be careful about that. The first term, its derivative is 0, so technically it got knocked out. So then that means that we no longer start at n is equal to 0 because there's no 0 term. Rather, we can go ahead and say that n is equal to 1 is our first term because this right here is going to be n is equal to 1. This is n is equal to 2. This is n is equal to 3, and so on and so on and so on. So that happened because we took the derivative and the first term is gone. Now, there's still going to be infinite number of terms, and infinite number of terms minus 1, we can still consider it as infinity. And in terms of what happens, right, remember, each term, you're taking its derivative. So the way it worked in here is that it's going to be n multiplied by 2x raised to the n minus 1 power, and then multiplied by 2, okay? So there is basically every single term in there. So you can see now that's going to be my series then. In terms of its interval of convergence, if you take the derivative, nothing is going to happen to it. You're not going to modify anything because, you're not shifting or anything like that. So it's still going to be the same thing. All right. Now, let's go ahead and apply the last parts of it, okay? I want to take what I have right now, which is this guy right here, and then I want to change it so that it's 2x instead on top rather than just negative 2. So why don't I just take my answer from right above, right? Which is this guy right here. This is currently what we have. And I am going to go ahead and multiply by x and also multiply by negative 1. So if I take my equation, multiply by x and also by negative 1, that will give me my final answer of what I'm looking for. And hopefully we will then have a series for this one then. So you take the whole thing over here, and then you multiply by negative x, I suppose, in this case. So then that means it's going to be negative x multiplied by this whole thing over here. So 2 plus, I guess you can clean that up if you want, but I'm just going to choose to leave it as is. 2 times 2x times 2, and then plus 3 times 2x squared times 2, and then plus 4 times 2x cubed times 2, and then plus all the other terms afterwards. And in terms of our series, well, we can just go ahead and multiply x also in there. So then that would be the summation of n is equal to 1 all the way to infinity. And then we said multiply negative x to all the terms. So then that would give us, let's see, 2 multiplied by n multiplied by negative x. Well, I'll just put the negative in front right there, and then multiply by 2x to the raised power of n minus 1. Interval of convergence, if we multiply by negative x and negative 1, that doesn't do much because we're not changing x once again, right? We're just multiplying something to the equation. So once again, it's going to be between negative 1/2 and 1/2. So there it is. That's going to be my series. This is going to, that's my equation. This is my series. And this is the summation form. And this is my interval of convergence then. Okay. All right. Let's try a few more examples just to see how this all works out. Okay. Because this could be kind of overwhelming. It is very overwhelming, if anything. Okay. So here it is. Here's the next one. I want to find out what is the power series for tan inverse of 2x. I want to find the power series for this one. So again, we're going to go ahead and start with what we know and then build from it accordingly, okay? Now, this one's a little bit tricky because, again, we don't really have much to work with. And, with the two that we have, these two series right here, the question is, well, how do we get to what we want? Needless to say, hopefully, you can hopefully expect that you're not going to use e to the x. So it's most likely going to be the first one somehow, okay? So let's go ahead and write that out. So we first start with 1 over 1 minus x, right? And you're thinking to yourself, okay, so what do I have to do to this equation in order to get what I want? Keep in mind, you can replace x with any kind of like composite function. You can take the derivative. Heck, you can even take the antiderivative. So here's how I'm seeing things. Take what we have, and why don't we go ahead and replace all the x's with negative x? So then that means we're going to get this then, okay? And then once we have that, that is going to give us 1 over 1 plus x. And then now if I take all the x's in here and replace it with x squared, then now we have 1 over 1 plus x squared. Well, that's a little bit closer to what I want, because if you recognize it now, that is supposed to be the derivative of tan inverse. So what that means is my next step is probably to take the integral of it, okay? So that right there would then give me the tan inverse that I need. And then finally replace all the x's with 2x. So there you go. That's going to be my procedure then. Now, is this the only procedure? The answer is no, because, if you're trying to get to the top of the mountain, there's definitely more than one way of getting there. So you basically find a way that works best for you and also the most efficient for you. All right, so let's go ahead and start it out then. So 1 over 1 minus x, that's 1 plus x squared, and so on again. The summation, the series, is going to be n is equal to 0 all the way to infinity of x to the n. And then we have negative 1 is less than x is less than 1. From there, we're going to go ahead and replace all the x's with negative x. So here, we're going to go ahead and subtract negative x right there. So in our series, wherever you see x, you're going to replace it with a negative then. So it's going to be 1, and then we have minus x, okay? And then the next part, if you have negative x, then that's going to make it a plus x squared. And then it's going to be minus x cubed, and then plus x to the 4th, minus x to the 5th, and so on and so on and so on. Again, you're just writing as many terms as you need so you can see what's happening. So this is equal to the summation of n is equal to 0 to infinity of negative x to the n, because remember, you're replacing all the x with negative x. In terms of our interval of convergence, if we replace x with negative x, this is what it's supposed to look like. And so if we multiply everything by negative 1, right, take this whole thing right there and multiply by negative 1, then you'll notice that it's just going to go back to the same thing because the inequalities will swap. And then also your values are going to multiply negative 1. So you'll notice it's basically the same thing. So it's just the same, okay? All right, so as of right now, this is what we have. 1 over 1 plus x then, okay? And then the next thing that we said is take our new series right here and replace all the x's with x squared. So 1 over 1 plus, and then now in parentheses, you're going to have to replace all the x with x squares. So in our series right here, it's going to be 1 minus, and then replace it with x squared, okay? And then plus the next part, replace it with x squared. So that's going to be x to the 4th. If you want to write it as x squared squared, that's fine. Or if you want to write x to the 4th, that's fine too. I'm going to go ahead and choose the latter and say x squared squared. Okay. And then the next one after that is going to be x squared. And then that's going to be cubed, right? And then, oh, actually, wait, that one's supposed to be negative because of what I have above. So I got to make sure that is still there and there. Okay, and then this is supposed to be 2 right here. Okay, let's go ahead and write it in red. And I think, we've written enough terms so you can see what's happening then. Okay, so here I am going to now have the summation n is equal to 0 to infinity. Now for the one previously, if it helps, maybe we should write it like this. The summation of n is equal to 0 and then to infinity. We're going to go ahead and factor out the -1, and then so that we have -1 to the n multiplied by x to the n. So now you can see that we can go ahead and replace all the x with x squared. So we still have the -1 to the n, right? Then we have x replaced with x squared. That is going to give us x squared, and then the whole thing to the nth power. Or you can write that as x to the 2n. In terms of our interval of convergence, the interval of convergence, what will happen here is that we have, keep in mind what we started with is -1 is less than, and replace x with x squared. This is what we're going to have, right? So if you take the square root of both sides, then what will happen is that you're going to get, let me go ahead and take a quick look at my notes, just making sure everything is okay. Where are we? Sorry about this, a slight little delay over here. Nope, nothing here. Okay, anyhow, so let's see. If you have x squared and then you take the square root of it, then that means that for the values of x that works, well, actually it doesn't change it, because if you take the square root, so technically here, let's kind of look at it this way. This part right here, we can definitely neglect. So then that way we would have x squared is less than 1. Right? Because remember, whenever you take the square of something, it's never going to be negative. Now you're thinking to yourself, okay, so for x squared is less than 1, for what values of x is true, you take the square root of both sides. And then when you take the square root of both sides, then you end up with positive and negative, because, if you have, like, say, x squared is equal to 1/4, right, then x is equal to -1/2 or +1/2. So that means that this basically gets us back to where we started with once again. So that's going to be our interval of convergence right now. So constantly, you have to make sure that you update your interval of convergence and also your formula also. Okay, we're almost there. We said the next part is to take the integral of it. So then that means the integral of it, 1/1 plus x squared. That right there, that is going to give us the tangent inverse that we're looking at. So we're almost done. So this part, this is where you have to be careful. So now we're going to go ahead and take the antiderivative. So if you take the antiderivative, let's go ahead and do it one term at a time, okay? So the first term, the 1 is going to give you, let's see, that's going to give you x. And then the next term after that, that negative x squared, that is going to give you, let's see, negative, and then it's going to be x to the 3rd, and then it's going to be divided by 3 right here. Then the next one after that, if I take its antiderivative, and if I'm considering that as x to the 4th, then that is going to be x to the 5th, and then it's going to be minus 1/5, actually plus 1/5. So here you can see that I actually multiplied it out just so I can take the antiderivative a lot easier. And I think you should actually do that too, just in case. Then the next one afterwards, it's going to be minus, it's x to the 6th, so its antiderivative is going to be x to the 7th. And then we're going to divide by 1/7, and then plus so on and so on and so on. And remember, you just write as many terms as you need until you see the actual pattern. Okay, so now we're going to go ahead and say, we're going to go ahead and write its summation form. And this part right here is going to be very, well, actually, we'll take care of this first, okay? So let's see. We can go ahead and say antiderivative. Okay, got it. So the summation of n is equal to 0 all the way to infinity. Now, in this case, it's still 0 because we didn't lose a term like we did when we took the derivative, okay? We're going to still have the -1 to the nth power. This guy, if you take its antiderivative, now think of what we just did right there, right? This is supposed to be x to the 2n. So by the power rule going backward, its antiderivative would be x to the 2n plus 1. And then we're going to multiply by 1 over 2n plus 1 because of the reverse power rule. Again, taking the antiderivative, and just like taking the derivative, it's not going to change your interval of convergence. So it's still going to be from -1 to 1. And now here's the part that's crucial. Since you took the antiderivative, then technically there should be a plus c that is over there. Okay, so there should be a plus c anytime you take the antiderivative. If you're wondering how do you solve for this value of c, well, what we can do is we can plug in to figure out what we know and don't know. Here, let me just kind of write that on the side right here. If let's say that x is equal to 0, then that means that tan inverse of 0 is going to be equal to 0, which is equal to, on the right-hand side, is going to be c plus a string of zeros because all those x's are equal to 0 as well. So when you clean that up, then you can see that 0 is equal to c. So then that means that my constant in this case is equal to 0 then. So as of right now, we have tan inverse of x is equal to just that thing that we just said then, right there. Okay, so that is going to be this part. And finally, afterwards, and you know what? Actually, I think it might be good if I just wrote this out because this one is probably good to memorize just in case in the future you might actually need it. Okay, so this is something that we might want to keep in our toolbox just in case. All right, so I'm going to go ahead and highlight it. So this guy right here, we're going to go ahead and keep. And final step is that we're supposed to replace all the x with 2x. So then my final answer is tangent inverse. Okay, so it's going to be tangent inverse of 2x. And that will now be 2x over here minus 1/3 times 2x to the third plus 1/5 times 2x to the fifth, and then minus so on, so on, so on. The important part is also always the summation. So just make sure you write the right one over here. So -1 to the n, and then all the x replaced with 2x over here. And there you go. And that's pretty much it. So the last part, the radius of convergence, that is going to change it so that all the x gets replaced with 2x. So then that means my new interval of convergence is from -1/2 all the way to 1/2. So that's part of my answer. This is my answer. And also this right here is going to be my answer then. Okay. All right. Now for this last one right here, what I want to do is I want to estimate what is this guy over here using what we just did. So then that way my error is going to be less than 0.001 within 3 decimal places. So if you can see what we've been doing so far, we can definitely find the antiderivative of this. Well, it's kind of like the other way around. We can't find the antiderivative of this by hand, and we can use it by a calculator, but we're trying not to. So what I'm saying is we're going to try to use the method that we've been doing so far to estimate what this is. So then that error, and in addition to that, our error is going to be less than 0.001. Okay, so again, start with what we know and then build it accordingly. So what we do know is that we know e to the x. That is supposed to be equal to 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial, and so on and so on and so on. And that is equal to the summation of n is equal to 0 all the way to infinity of x to the n divided by n factorial. The radius of convergence in this case is supposed to be all real numbers, so we don't have much to mess with over here. So looking at what we have right here, I think what we're going to need to do is going to have to do like a replacement. We're going to go ahead and do it one step at a time. Let's go ahead and introduce the negative first. So e to the negative x is going to make this alternation over here. So 1, and there will be minus x over 1 factorial, and then plus x squared over 2 factorial, and then minus x cubed over 3 factorial, and so on and so on and so on. So that is going to change my summation so that it's going to be -1 to the n multiplied by, well, I guess if you want to like actually see the work over here, it's technically replace all x with -x, right? And then divide by n factorial. And if you want to simplify that just to make your life a little bit easier, you should go ahead and do so. So n is going from 0 to infinity of -1 to the n times x to the n divided by n factorial. Changing that, let's see, the interval of convergence is still going to be the same thing, because if you replace all the x with negative x, you're still going to have all real numbers then. Next, we're going to go ahead and replace all the x with x squared. So then that is going to look something like this. So on the right-hand side, then we have 1 minus, and then this part is now going to be x squared, right? And then divided by 1 factorial, and then plus the next part that's going to be squared, divided by 2 factorial, and then minus the next part that's going to be cubed, and then divide by 3 factorial. And all those replacements are going to be x squared. So x squared, square, x squared, and so forth. And we'll just go ahead and write that many terms because we can see what's happening here. The summation is n is equal to 0 all the way to infinity, -1 to the n. And then we have all the x replaced with x squared. So I do believe that's going to be x raised to the power of 2n then. So x raised to the power of 2n, and then divided by n factorial. And your interval of convergence is still going to be from x, that's all real numbers. Okay, as of what we have right now, we've already built this part. So now we're going to need to implement the x squared. So we're just going to go ahead and multiply everything by that then. So then multiply everything by x squared. So x squared multiplied by e to the negative x squared. Then that is going to be equal to x squared minus x to the 4th divided by 1 factorial, plus x to the 4th, then x to the 6th divided by 2 factorial, and then minus x to the 6th, so that's x to the 8th divided by 3 factorial, and so on and so on and so on. In our summation, I'm just multiplying by x squared, so the -1 to the n doesn't change. The x times 2 to the n, sorry, x to the 2n, that doesn't change also. Multiplied by x squared, so that means just multiply by x squared like this. And then all divided by n factorial. And we're still going to have from all real numbers then. One thing that I would suggest is, because the next part says I'm going to take the integral, is probably take these two guys right here and combine it together so you can see what that becomes then, or what that looks like when you take the antiderivative. So summation, n is equal to 0 to infinity, -1 to the n, x to the power of 2n plus 2, and then divided by n factorial. Okay, now we're going to go ahead and take the antiderivative of it. So the integral of x squared times e to the -2x. So that is going to give us now the first term. That is going to be x to the 3rd, and then we're going to divide by 3. The second term, we're going to go ahead and take its antiderivative. So that's going to be x to the 5th, and then divide by 5. And then there's also that 1 factorial. And then the term after that is going to be plus x to the 7th. And then we have divide by 7 multiplied by 2 factorial. And then afterwards, it's going to be x to the 9th. And then it's going to divide by 9 and then multiply by 3 factorial on the bottom. And then plus, so on and so on and so on. In terms of our summation, that is going to be now the summation of n is equal to 0 all the way to infinity. Still -1 to the n. And then the antiderivative. So that is going to give us x to the power of 2n plus 3 in this case, because we add 1, right? Since we took the power rule backwards. We still divide by the n factorial, and then multiply, or sorry, divide by 2n plus 3, because again, the backward power rule. And then from x all the way to infinity, for all real x's like there. Okay, in this case, we don't have to implement the plus c because there is no there's no integrating constant since we're taking the boundaries of this. Remember, we have a boundary of 0 to 5. So at this point, what we usually do is we plug in the upper bound and then after that subtract the lower bound. So here, if I want to solve for what we really want at the very end, right? On the right-hand side, I am going to go ahead and plug in 0.5 to all of this. And then afterwards, minus plug in everything that's 0 afterwards. So let me go ahead and rewrite this because I accidentally erased it. Let's see. Hold on. It's going to be 1 divided by 3, and then we have x to the third, and then we have minus 1 over 5, 1 factorial, and then x to the fifth, and then we have plus 1 over 7, x to the seventh, and then 1 over 9, and so on. Okay, so we're going to plug in 0.5. So 1/3 multiplied by 0.5 to the third power minus 1 over 5, and then multiplied by 0.5 raised to the fifth power. And then plus 1 over 7 times 2 factorial. So let's just go ahead and write that at 14 at this point, right? Because there's no point of keeping it in that form anymore. So 14 multiplied by 0.5 raised to the 7 factorial. And then minus for the other one is going to be 1 over 9 times 3 factorial. So that's 9 times 6. So that's 54 multiplied by 0.5 raised to the 9th power. And so on and so on and so on. So that right there is going to be our series then. Now, since I want the error to be less than 0.001, then what that means is you're going to have to find out what each term is equal to. And as soon as you have a term that is going to be less than 0.001, then that is the term that you're going to strip away, and everything else before it is going to be okay. So doing the math right here, what I notice is that this guy right here, actually it's not this guy right here, it's this guy right here, okay, not this one. If I take the absolute value of it, 1 over 14 times 0.5 raised to the 7th power, that is approximately equal to 5.58 times 10 to the negative 4th power. And notice that this guy right here is definitely less than 0.001. So that means that all you have to do is just sum up the first 3 terms over here, and then you're going to be pretty close to your estimate then. And in terms of what that is numerically, that is equal to approximately 0.0359 then, okay? All right, so there you go. Thank you so much for watching. I will see you guys next time. Have a good one.